Have you ever pondered over the nature of energy and its unseemly, discrete behavior? Picture a time when the world believed that energy flowed smoothly, like a river, uninterrupted and continuous. But in the dawn of the 20th century, a revolutionary idea emerged, one that dared to challenge this long-established belief. Enter the concept of energy quantization, the idea that energy, rather than being continuous, is emitted or absorbed in distinct packets, or quanta. This was a quantum leap in thought, a groundbreaking concept that rattled the foundations of classical physics. The mastermind behind this revolutionary idea? A German physicist named Max Planck, a man whose life was devoted to scientific research and who showcased exceptional skill in mathematics and physics. His introduction of energy quantization marked a pivotal moment in the history of theoretical physics. The man to challenge the classical principles of physics was none other than Max Planck. Max Planck, born in Kiel, Germany, showed an early penchant for mathematics and physics. As a young boy, he was fascinated by the mysteries of the universe, always questioning, always exploring. He was a curious child, drawn to the intricate patterns of numbers and the laws of the physical world. His intellectual journey began at a very young age, his mind a fertile field for the seeds of scientific thought. In school, Planck showcased exceptional skills in both mathematics and physics. He was not just another diligent student, he was a prodigy, a young star eager to shine. His teachers saw in him not just a keen intellect, but a passion for understanding the fundamental truths of reality. This was the start of his scientific career, the beginning of a journey that would change the course of physics. Planck was not only a scientist in the making, but a prodigious talent waiting to revolutionize the world. The year 1900 marked a turning point in physics, thanks to Max Planck. This was the year when Planck introduced the concept of energy quantization, which forever changed our understanding of the physical world. In a nutshell, energy quantization is the idea that energy is not continuous, but comes in discrete packets or quanta. Imagine a jar that can only be filled with marbles of a certain size. You can't have half a marble, just like you can't have half a quantum of energy. This concept was revolutionary at its time, challenging the principles of classical physics that had held sway for centuries. Classical physics, with its roots in the work of Isaac Newton, described a world of smooth and continuous processes, but Planck's theory suggested that at the microscopic level, the universe is a bit more choppy. Energy, it turns out, is a bit of a picky eater, preferring to nibble on its food in specific-sized bites. The significance of this discovery cannot be overstated. It was like discovering a new continent in the world of physics, a land where the laws of the familiar world didn't apply. This was the birth of quantum theory, a new branch of physics that deals with phenomena on the microscopic scale, such as atoms and subatomic particles. Planck's work shook the scientific community to its core. It was a bold assertion, a daring leap of thought that demanded a radical shift in perspective. But as with all great scientific revolutions, it didn't happen overnight. It took time for Planck's ideas to be accepted, and even more time for their full implications to be understood. The journey of quantum theory was not a smooth one. It encountered resistance, skepticism, and even outright hostility. But ultimately, the evidence was overwhelming, and the scientific community had to accept the reality of the quantum world. Planck's quantum theory was not just a scientific revolution, but a quantum leap in our understanding of the universe. It opened the door to a new way of seeing and understanding the world around us, a perspective that continues to shape the course of scientific inquiry to this day. Planck's influence on physics didn't stop at the quantum theory. In fact, his further explorations in the realm of quantum mechanics led him to formulate what we now know as the Planck constant, represented by the symbol h. This constant is a significant player in the world of quantum mechanics, linking the energy of a photon to the frequency of radiation. You see, the Planck constant is the key that unlocks our understanding of the behavior of subatomic particles. It's the bridge between the macroscopic world we live in and the microscopic world of atoms and particles. In essence, it's a quantum connector, enabling us to relate the energy of a particle to its frequency, a principle that's fundamental to our understanding of the quantum world. This groundbreaking constant didn't just make waves in the scientific community, it caused a tsunami. The Planck constant challenged the accepted norms of classical physics, shaking the very foundations of our understanding of the universe. It was a bold proposition, one that dared to redefine the rules of the game. And the world took notice. In 1918, Planck was awarded the Nobel Prize in Physics. This wasn't just a nod to his brilliant mind or his revolutionary constant. It was an acknowledgement of the seismic shift his work had caused in the world of physics. The Nobel Prize recognized the profound impact of his contributions to quantum physics, highlighting how his work had reshaped and redefined the field. Planck's constant was more than just a number. It was a testament to his belief in the power of reason and the pursuit of knowledge. It was a symbol of his unwavering commitment to scientific truth, and it was a beacon of hope, signaling a new era in our understanding of the universe. Planck's constant became a cornerstone in the edifice of modern physics and earned him the highest honor in the scientific world. And so, the legacy of Max Planck continues to illuminate the path of scientific discovery, lighting the way for future explorations into the quantum world. Planck's dedication to science did not waver, even during the tumultuous times of the World Wars. As conflict engulfed the globe, Planck found himself in the heart of the storm, in Germany, his homeland. He would play a significant role in the scientific community during these times of crisis, demonstrating the strength of his character and the depth of his convictions. During World War I, Planck supported his country's scientific efforts, believing in the power of knowledge to shape and improve the world, even in the throes of war. He was a respected figure, providing guidance and leadership to scientists who were navigating the complex intersection of scientific research and wartime necessities. His unwavering commitment to the pursuit of knowledge was a beacon for many during these dark times. However, when the Nazi regime rose to power, Planck found himself at odds with the destructive ideologies that were spreading through his homeland. Despite the risk, he openly opposed Hitler, standing firm in his belief in academic freedom and the pursuit of truth. His courage was not only a testament to his personal integrity, but also a powerful demonstration of his belief in the fundamental principles of science. His defiance against Hitler was a bold stand for academic freedom. He championed the idea that science should not be constrained by political ideologies or agendas. His advocacy for the independence of scientific research was a rallying call for scientists across the world, reinforcing the importance of objective truth in the face of oppressive regimes. Even under the most challenging circumstances, Planck never lost sight of his principles. His unwavering belief in the power of knowledge and the importance of academic freedom was a beacon of hope for many in the scientific community. In the face of adversity, Planck stood resolute, advocating for the integrity and independence of scientific research. His courage and conviction during these tumultuous times echo through the annals of history, reminding us of the strength and resilience of the human spirit when armed with the power of knowledge and the pursuit of truth. Max Planck's life was a testament to his unwavering ethics and dedication to scientific truth. The profound legacy of this luminary physicist continues to echo through the corridors of scientific discovery, shaping our understanding of the physical universe. His extraordinary work in quantum theory, which proposed that energy is emitted or absorbed in discrete packets called quanta, revolutionized the field of physics. This groundbreaking concept challenged the classical physics principles of the time, setting a new course for scientific exploration and understanding. Today, quantum theory is a cornerstone of modern physics, underscoring the far-reaching implications of Planck's pioneering work. But Planck's influence wasn't confined to abstract theories and quantum mechanics. His work touched the minds and hearts of some of the most celebrated scientists of his time, leaving an indelible mark on the scientific community. Prominent figures like Albert Einstein, Niels Bohr, and Werner Heisenberg were deeply influenced by Planck's innovative ideas and profound insights. Einstein, renowned for his theory of relativity, was one of Planck's earliest supporters. He once noted that it was Planck's work that opened his eyes to the mysteries of the quantum world. Niels Bohr, a key contributor to atomic structure and quantum theory, and Werner Heisenberg, the father of quantum mechanics, also drew heavily from Planck's groundbreaking research. But perhaps the most enduring part of Planck's legacy is his unyielding commitment to the integrity and independence of scientific research. He was a staunch advocate for reason and the pursuit of knowledge, standing up against the Nazi regime in defense of academic freedom. He believed in the power of science to enlighten and improve the human condition, a principle that resonates with scientists and researchers around the world today. Max Planck, a committed humanist and extraordinary scientist, has left a legacy that continues to shape our understanding of the universe. His life and work serve as a powerful reminder of the transformative power of scientific curiosity and the enduring value of intellectual courage.